Hi, this is Litcham Science Department and we are going to tell you about GCSE Science. Firstly, I'm going to tell you a bit about the course. Welcome to GCSE Science, but you have actually already started studying this course because we started in Year 9. Depending on which class you're in, you're either taking separate sciences in 10.1 or combined science in the other science classes. If you are taking separate sciences, you will get 3 GCSEs at the end of Year 11, and in the other classes you will get 2 GCSEs. And the grades can range from double grade 9s to double grade 1s, depending on whether you take higher or foundation tier. Don't panic, we can make a decision on which tier you are going to take into Year 11. You'll realise that you're being taught by subject specialists, so you have different teachers for biology, chemistry and physics, and this year we do have a mixture of theory and practicals, so we're doing a lot more experiments, not just the core practicals. Mr. Chown is now going to talk about the core practicals in more detail.
So in total there are 18 core practicals that you complete in the combined course, and there are a few extras that you complete if you are doing the triple course. Throughout these core practicals, you're no longer assessed on your practical skills. It is more that you will be asked questions about it in your exams. And so the way that we assess them in lessons is we get you to complete the practicals, and then there are a range of questions that you'll be asked about it that we as your classroom teachers will assess. In total, your final exams are made up of almost 20% of your exams are based around the core practicals. And so they're really important knowledge for you to have in order to receive the highest grades possible.
This is an example of one of the core practicals that you will be completing. So in this example here, we will be looking at chromatography. So this is a nice one because it's very visual. You're able to see how it's able to separate the colours. So chromatography is a separation technique that you'll learn about in Year 9. So I'll just run you through the method now. To begin with, you need to use your piece of chromatography paper here, and you're going to draw a line about 1 to 2 centimetres above from the bottom up across on your piece of paper, and you're going to draw it horizontally across there, and you're going to use pencil when you're doing that. We're using pencil because it's not soluble in our solution, which in this case is our water. So we've drawn a horizontal line across there. And then what we're going to do is we're going to take a variety of different colours and put spots of ink at the different places. So we'll put one just above the line here. We'll also use another colour. We'll put another dot here. Again, making sure that they're just above the line. Lastly, we'll also just use a regular pen, and we'll make a dot of that ink in the middle. However, we should see that this one doesn't separate in the same way as our other two colours do, due to the fact that this ink isn't soluble within the water. And so to complete the experiment, all that you do is you take your piece of chromatography paper. All we've got in here is some water. You place your piece of chromatography paper inside of the beaker, and you make sure that your piece of chromatography paper goes into the water, but the water doesn't go above the pencil line that we made earlier in our chromatograph. And so what will start to happen is that the water will start to rise up the piece of paper, and it will start to separate out the different colours of ink that we've got. So as you can see here, here's an example that I produced earlier. And again, we have our 2 different spots, well, we have our 3 spots of ink that we started with. And you can see here again that the 2 that are both soluble within the water have separated out into their different colours, whereas our ink in the middle that isn't soluble in water has just stayed on our line as we begin there. Now, when you continue on with chromatography, you can also calculate something called the RF value. So the RF value is just working out how far this is separated relative to how far the water has gone on your line. So for example, if our water was to go up to here, we would measure how far our water's moved. We'd also measure how far our ink spot has moved. And then in total, we'd be able to work out the RF value by dividing how far this ink has moved and dividing it by how far our solvent, which in this case is our water, has moved as well.
So having completed the practical, These are the type of questions you'll then be asked to complete after doing it. So for example, this one here is talking about a slightly different chromatography where it's using propanone as your solvent instead of water, which is what we used in the practical above. So question 5a asks you to identify the mobile phase and the stationary phase in the experiment. So for both the experiment that we've just seen with water and for this one here, our stationary phase is going to be our piece of chromatography paper. The only thing that's different is the mobile phase. So in the experiment that I showed you a moment ago, the mobile phase would be the water, whereas in this experiment here, the propanone becomes the mobile phase. Then there are other questions as well that you complete, somewhere between 3 and 10 questions, depending on the experiment itself. So this is an example of a sticker that we would use to be able to assess your core practical. As you can see, there are various key skills that we as your classroom teacher are looking for. There's also an area for you to self-assess to work out whether you have completed the practical and completed all the different things that we're going to be looking for. As you can see at the bottom as well, there is an area where we can give you guidance on to how to improve. It might be how you could improve the experiment that you completed, or generally the detail or the quality of your written answers that we give you feedback on.
So now I'm going to tell you a bit about the exams. At the end of year 11, there are actually 6 exams, and that's for everyone, whether you're doing separate or combined science. In combined science, the exams are 1 hour 15 each, and in separate sciences, the exams are longer. They're 1 hour 45, but you are taught more content. This means you get 2 biology papers, 2 chemistry and 2 physics. And that's for both courses. We also assess you continuously by doing topic tests at the end of each topic. And as Mr. Chown explained, we also assess you when we look at your core practical, how you do the experiment, and also how you answer the questions. So we have a really good idea as to what level you're working at throughout the course from year 9 all the way through to year 11. So now I'm going to tell you how to succeed in science to get the best GCSE grades possible. Firstly, you absolutely need to work hard in lessons, listen really attentively, ask questions if you're not sure, and make sure you complete all the work to the best of your ability. Make sure you do your homework. I'm going to show you an example of a mind map that you might be set for revision. Other homeworks might be a bit of research or practice questions or a worksheet where again you're consolidating your knowledge. We really recommend you use Active Learn to support and consolidate your learning. If you're not sure what your login details are, do see me as soon as possible and I can set that up for you. This gives you access to an electronic version of the textbook. So when you're doing your homework, when you're doing your revision, do refer to your exercise book notes and also the electronic textbook on Active Learn to actually make sure you get the correct answers. You'll be purchasing revision guides, so make sure you use those regularly, and I'll show you some examples shortly. And also I really like it when pupils use interactive notebooks. They're a good way to get keywords in one area, and I will show you how to actually make one of these as well. I'm going to show you some of the ways to succeed in science that I spoke about before. So firstly, when you get your revision guides, make sure you use them really interactively. There's a higher and combined version, and there's also a workbook. So when you're revising, you could maybe look up a particular topic, write down key points, close the book, and see if you can actually redo them, get that retrieval practice in to make sure it goes into your long-term memory. The other thing I wanted to show you was a mind map. So for example, here is a mind map on chromatography. Just look at the other side. And you'd maybe fill this in class as an activity, or possibly it's been set for you for homework. You could look up the answers for particle diagrams in your exercise book. So solids would be very close together and in rows. And then the liquids are touching, but in more of a random pattern. And then gases are much further apart. If we look at the chromatography section, Mr. Chown's been talking about that. When you're revising, you could talk about the fact that for chromatography to work, different colours have different solubilities. the more soluble colours travel up further, travel up the paper further. The mobile phase is always the solvent, whatever that is. It could be water, it could be oil, it could be propanone. The stationary phase is always the chromatography paper. Once you've made your mind map, really important thing is to be able to actually cover up the different sections, see if you can redo it from memory. You can get scrap paper or you could get a notebook and write things in, but try and use your mind maps really interactively to test that you have actually retained the information and put it in your long-term knowledge. A really good way to revise is to make an interactive notebook, which I mentioned earlier. So if I show you an example for the chromatography keywords, you would have a piece of paper, A4 is fine, or it could be a piece of card. I've cut this into 3 tabs. On the first one, I'm going to write RF value. On the middle one, mobile phase, you need to know what that means. And the last one, stationary phase. Then inside you can write the definition, so kind of like a flashcard, but it's all in one area. So the RF value is a calculation. It's the distance moved by the colour. I'm just going to summarise that a little bit, divided by the distance of the solvent. It'll always be 0 point something. It's always going to be less than 1. So if you have a number greater than 1, you've done the calculation the wrong way round. So someone can now test you. You can test each other in lessons, or you can test each other at home as well, or maybe a parent or carer could test you. The mobile phase is the solvent. So it could be water, it might be oil, or it might be propanone. It's whatever the colour or the dye or the ink is going to be soluble in. And the stationary phase is always the same thing. Whatever chromatography you are doing, it's going to be the chromatography paper. Once you've made that, you can stick that in your book. Unlike flashcards, they won't get lost, they're stuck in, and you can refer to them regularly and get people to actually test you. So yeah, they're a really good revision resource. Now I'm going to talk about careers, and there are tons of careers you can do that link to science. There are some examples here. Also, you may want to work in healthcare, engineering and construction, the energy industries, and don't forget that includes renewables or animal care. Even if you don't particularly want to pursue a science career, fantastic GCSEs in science will definitely be helpful. And also, by studying this course, you will develop your employability skills, such as being able to follow instructions, leadership and teamwork. It will only be beneficial to you to do well in science.